Okay, this is homework for Monday, February 22nd. It's on page 57. You are doing 5.2b number 1. You should already have it completed and you're just here to check your work. So A asks you to look at each of the situations with the cars and their time and distance and tell which ones are linear functions and explain why. So what it's trying to get you to realize here is that a table or a situation can be a function, but not a linear function. So for instance, all of these are functions because all the inputs have one unique output, but that doesn't mean that they're all linear functions. Linear, as you have learned in the past, means that there's a constant rate of change, you can find a slope, and if you graphed it, it goes in a straight line. So for each of these tables, I need to see if there's a constant rate of change. And to do that, I'm going to put in my carets. So from 4 to 7 is 3, 7 to 10 is 3, 10 to 13 is 3, not 13, and 13 to 16 is 3. Okay, so I know that that's a constant rate because I can do 3 divided by 1 because all the carets on this set are 1, and I end up with 3. Okay, so car 2, from 2 to 5, I'm going to do a different color. From 2 to 5 is 3. From 5 to 10 is 5. From 10 to 17 is 7. And from 17 to 26 is 9. So there definitely is a pattern. It's starting to go like faster by 2 feet every time, but there's no constant rate here. And even if I added all these up together and divided by 4 to try to get a slope, it wouldn't work for this situation. Okay, and now car 3. From 3 to 5 is 2. From 5 to 9 is 4. Whoop. From 9 to 17 is 8. And from 17 to 33 is 16. So again, no constant rate. So when I'm answering A, I could say car 1 equals linear function because it has a constant rate of 3. And then cars 2 and 3 equals not linear because they do not have a constant rate. Okay. Now B was asking for any of the data sets that can be modeled by a linear function, write a function that models the distance traveled d and the function of time t. So it's asking us to write an equation using d and t instead of y and x. And the only one that was a linear function was car 1. And so I'm going to look back at car 1. My slope was 3 and I have to work backwards to find my y-intercept. So if this goes back 1, this goes back 3, which means at 0 it is 1, which is my y-intercept. So my equation would be d equals 3t plus 1. You could label it d is total distance, in feet. 3 is 3 feet per second. T is number of seconds. And 1 is at 0 seconds you start at 1 foot in distance. Okay, C says, what is the dependent variable and the independent variable? Okay, so I know that the dependent variable is also the y. So in this case, it is distance, because the distance relies on or is dependent on the time. And then the independent variable is the time in seconds. Okay, you could have just used the tables to figure that one out. Now D is asking which car is going fastest and justify your answer. So I went back to what we already know. I know that this one's going 3 feet per second. And that this one, it's like enhancing the feet by 2 every time. So like instead of going, because it starts off going 3, but then it starts going 5, 7, 9. So it's like increasing by 2 each time. And then for car 3, it's doubling because it starts off at 2 feet in 1 second, and then it goes 4 feet in 1 second, and then it goes 8 feet in 1 second, and then it goes 16 feet in 1 second. So this one is doubling its distance each second. So that's why it's going the fastest, car 3 is. And also I can look after 5 seconds, it's gone the furthest. It's gone 33 feet, while the other ones have gone less. So car 3 is traveling faster. Okay, that is the end of homework today. I will see you tomorrow.